Welcome! In this series of short videos, we will look at topics common to the PowerBasic Windows compiler. Today we will look at using a progress bar to give users feedback on loading delays. In today's video, we're going to look at another form of user feedback while an application is running, the progress bar. I created a very simple skeleton of our application. This has two buttons on it, the progress bar and a simple label control. The idea behind this application is to simulate an application running under load. Once the user clicks the start button, a function will commence, which will then do some processing. As the processing progresses, it will advance the progress bar to let the user know that it's actually still running. So let's have a look at the code. In the dialog creation function, this is where we specify all the objects to appear on the dialog, the two buttons, the label control, and the progress bar. When you use the Forms Designer to add a progress bar, it quite happily adds in a little function for you to set the value and the range of the progress bar. There are two commands within this function, a progress bar set range and a progress bar set position. The set range sets the lower and upper boundings of the range of the progress bar values. In this case, we're setting it between 0 and 100, which is ideal to show a percentage complete. The progress bar set pause is a set position command. This will set the value of the progress bar. So in this case, we're giving it three parameters: the handle of the dialog, the handle of the progress bar, and the value we wish to set, in this case the value of 1, as in 1% complete. In our callback function, our event handler, this is where all the messages are handled for the dialog. In the WM command section is where we're handling the events for both of the buttons. The exit button is ID abort. When that button is clicked, we're exiting the application by closing down the sole dialog. We have not yet put any code underneath the start button, which in this case is ID OK. So we're going to put our first code in this event to start the processing. In this application, when the user clicks on the start button, we're going to start doing some processing. To avoid the user clicking on the start button multiple times, we will, as soon as a user clicks on that button, disable that button itself, using the control disable command. It takes two parameters, the first being the handle of the dialog, and the second the handle of the control. We can use cb.ctl as the handle of the control. Now we're going to update the info box at the top of the dialog to tell the user that the processing has now commenced. And I'm going to use a logging function to log the message that the processing has now started and the time to a file. We'll set that function up shortly. Next, we would want a processing function. We'll pass it a single parameter, which is the handle of the dialog. We'll create that function in a moment, but after that function completes, we can then tell the user that the processing has now finished, we can log this to our file, and we can re-enable the OK button, the button the user clicked to start the process off. So using a control set text, we'll update our label on the dialog. Then calling the fun log to log the finishing of the processing, and then re-enabling the OK button, the start button the user clicked to start off the process. So let's create our logging function next. We will declare a global variable to hold the path and the name to our log file. And in the pb main function, we can actually populate that using two of the inbuilt commands, xepath to give the path to our executable, and xename$ to give the name of our executable, excluding the extension, and then merely appending to the end of that an underline log.txt. That is now the name of our log file. So to ensure that that file is erased every time we run the application, we will do a simple try catch to kill the file. If the file does not exist, the program will not error. If the file does exist, it will be erased by the kill command. Now we can create our start processing function, which takes a single parameter, which is the handle to the parent dialog. The sole purpose of this function is to give the application something to do to demonstrate how our progress bar will actually function. So what I have set this function up to do is a nested for next loop. It will run round this loop many times. In this case, 200,000 for the outer loop and 5,000 for the inner loop. As it exits the inner loop, I want to do an update of our progress bar. But as we're running round the outer loop 200,000 times, I don't want to call the progress bar update 200,000 times. Since our progress bar has a range of between 0 and 100, this will report the percentage done. So I've worked out the step by dividing the maximum number, which is 200,000, using an integer division by 100. So the step will give us a position between 0 and 100 to tell us how far we've got. We can then use the mod command. So dividing along r by a long step, if that gives you a 0, that's the remainder. Therefore we're on a percentage boundary. So we know we've made 1 more % of progress. So we can then update our progress bar using the progress bar set position command. All this is fairly straightforward, and you may well have done this before with progress bars. We're then logging the percentage to our log, just to give the application a little more to do. Our final task in this section is to create the logging function itself. This takes our single parameter, which is the data we wish to write to the log. I'm using the static command in here to declare a local variable handle. The first time this function is called, long file will indeed be 0. If that's the case, then we have not allocated a handle for the file yet. So we will pick up using free file. We will then open the file for output. The next time this function is called, long file will be populated. Using the static type of variable allows this function to remember the value of the variable the next time it is run. So for the second and later iterations, we will be appending to the file, and it will quite simply use a print command to print the data out to the file. If we run our application now, we will see that the dialog comes up. If the user clicks on the start button, it says it's now progressing and the progress bar starts moving. However, if the user attempts to move the dialog, everything stops running. It gives them the message that the application is not responding and the progress bar stops moving. At this point in time, the user would think your application has crashed. However, once the application finishes, our progress bar reaches 100% and we get the finished processing message up. So what has actually happened to stop the application updating the progress bar on the dialog when the user attempts to move or minimize the application itself? In this scenario, where the user has clicked on a button and it takes some time for that function to complete, it's quite likely the user will actually switch to another application to do something else while they're waiting. If our application comes up to say it's not responding, this may set the user into a panic. Has the application crashed, or merely just stopped responding? The problem with our application in this mode is that the work being going on in the background, our function to start the processing, is in fact hogging all the resource for this particular application, and there is not enough time slot left for the dialog to update the progress bar. So how can we get around this issue? How can we update the progress bar while the application is still processing? As in all programming issues, there's usually more than one way to solve the problem. But what we're going to look at today is using a thread. We're going to amend our processing function into a threaded function, and we're going to create a couple of custom events to handle the event of needing to update the progress bar and the event when the application has actually finished processing. This will allow the user to move the dialog around the screen or to minimize it, and it will still continue to update the progress bar. So firstly, we will create two custom events, setting up at the top of the application two constants, one called progress event, which we will use for the event of updating the progress bar, and one called progress completed, which we will use to indicate back to the event handler that the background process has now actually completed. And since we're going to be using threads, in this case we're going to be using only one thread. But we'll set a constant up called total threads, and make it equal to 1. We will then set up a simple global array to hold the thread handles. Again, we're only doing one thread here, but this gives you the possibility of setting up additional threads for other types of functions. Now that we have this infrastructure in place, let's have a look at the event handler, our callback function. One of the things we'll want to know within this callback function is the status of the thread we have created. So we're going to create a local variable called longStatus. You'll see how that's going to be used in a moment. So if we look inside the event where the user has actually clicked on to start the process running, we'll comment out the existing function that starts the process. And we're going to create a new function which is a threaded function. We do this by using the thread create command. We then give our function a name, in this case start threaded processing, and threaded functions can only use one by val parameter, either a long or a d word. We're using it in this case to pass the handle of the dialog, which is a d word. And the output from this function is going into our array, which we're using to hold the handles of each of the threads. As there's only one thread here, we can pass it a parameter of 1. When this code actually runs, the thread create function will create and run the thread. It will then come back immediately and go for the next line of code, which in this case would have been the message to say to the user that it's finished processing. But in this case, we don't want to run these 3 lines of code because the processing will be running away in the background. So we'll comment all 3 of these out. We will create that new function in a moment. But before we do that, since we're in the event handler, we'll create the 2 new events we're going to use to handle the output from the thread. As we said, there's a progress event and a progress completed. The progress event message will be triggered by our threaded function. And in calling this progress event, it's going to be passing a piece of information to say what to set the progress bar to. It's going to come in the cbwparam value. We'll cover that when we get to the threaded function, but all we're using here is the progress bar set position, passing it the parameters of the dialog, the progress bar, and the value we wish to set. Once our threaded function has completed, we will then post a message to progress completed. In here, we can actually use the thread close command to close off that thread. Now that we know that the thread has actually completed, we can actually update the screen to say we have finished processing. We can write to our log to say that the processing is finished, and we can re-enable the OK button, the button the user clicked to start the process running. So now all we have to do is to create the threaded function itself. This threaded function is going to do everything that the start processing function actually did. As we said before, threaded functions can take only a single parameter. In this case, we're passing by value the dialog handle, which is a d word. And all the variables we had set up for our start processing, we can set up for our threaded function. The only difference between this threaded function and the other function we used is that we can't use the progress bar set command in here. We're going to take that out and we're going to replace that with a post command. We can use the dialog post command to post back to our progress event. Since we've calculated the value of long%, which is the percent complete of our function, all we need to do is dialog post, the handle of the dialog, the event which we're calling, and then 2 further values. We only need the first value, the wparam, in this case, which is the percentage value. The dialog post command sends a message back to the event handler of our dialog, and then continues immediately on to the next line of code. Once we have got to the end of our for next loop, we can then say that everything has been completed, and we can use another dialog post command to post to a progress complete event. So before we run the application, there's one more change we need to make to our PB main function. We need to dimension the global array for our thread handles. So we're dimensioning this array from 1 to 1. It's a very small array just to hold the value of our single thread. So we compile our application now, and we can attempt to run it. If we double click on the exe, the application comes up, and if we click the Start button to start processing, the dialog starts updating, and if we attempt to move the application now, it doesn't stop responding. It continues to update the progress bar even if we minimize and re-enable. So what we've achieved using this threaded function is allowing the user to have full control of the dialog, even while something else is processing in the background. This is a good mechanism to allow the user to get feedback on what your application is actually doing, even while the user is possibly doing something else in the application. And will of course avoid any non-responding messages to the user. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.